Okay, for example number 2, they want us to graph y equals 3 cotangent of x over 2 plus 1. Now the problem with that is if you look on the calculator, I don't have a cotangent button. So what we need to remember is that cotangent of theta is equal to cosine of theta all over sine, right? It's the reciprocal of tangent, so we flip-flop the sine and cosine. Does that make sense? So we're going to have the same issue that we had before, except now we're worried about when sine equals 0. So what that means, hey, wait a second. Is there a way, do you guys think that there's a way that I could graph this? Because I do have a sine and a cosine button, don't I?
Yeah.
So now, let's write this out by hand and see if we get this right. So y is equal to 3. This is what I need to replace, right? So what do I put in the parentheses?
Couldn't you take...
Yeah, so it's cosine over sine. We know that. But how do what do I put in the parentheses? Yeah, it'd be x over 2 for both of them. The exact same, like this.
Oh, what? Oh, got it.
Another way that you could do it, you could say y equals 3, 1 over tangent of x over 2 plus 1. And I apologize, I'm having some problems with the calibration of the whiteboard. But that's tangent of x over 2. Right? Because cotangent is also equal to 1 over tangent of theta. Those two equal the same thing. Right? Does that make sense?
Sure.
All right. So I'm going to graph both of them to see what they look like. What's the 3 going to do?
It's going to stretch it.
It's going to stretch it.
Wait, but last time didn't it compress it?
Well, it did. There's a horizontal compression.
Oh, this
And yeah, this one's vertical, right? So the 3 will stretch it vertically. What will dividing by 2 do in here horizontally?
That'll shrink it.
Well, wait, we multiplied by 2 and it shrunk it. So what will dividing by 2 do?
Stretch by 2.
It'll stretch it horizontally. And what will plus 1 do?
Move it up or down the left.
Move it up or down. So the transformations are basically pretty much the same. Stuff inside the parentheses can shift left or right, or if you multiply inside parentheses, it can horizontally shrink. The A term, the amplitude in the front, that will vertically stretch or shrink. And then plus a constant is always going to shift it up or down depending on whether it's positive or negative. So we just want to see what the graph looks like. So I'm going to try this. I'm going to do the first one, and as I do it, I want you guys to do it on your calculators as well. So we're going to say 1 divided by tangent of x divided by 2 plus 1. Does that look right there?
Yeah.
Then I'm going to clear this out, and I'm going to clear this out, and I'm going to come back up here, turn my thing on because I had it turned off for example number 1. 3, and then in parentheses, now this is where it gets tricky, I'm going to say cosine of x divided by 2 divided by sine of x divided by 2, close all that in parentheses, plus 1, I think. And if I did it right, it should all line up.
Sine of...
Wait, what's that blank space?
Well, we're going to look and see in just a second.
That's
Isn't it a horizontal
It's
axis?
divided by the sine of x over 2.
Mm-hmm. Okay. So that's the same, but the blue one, we got something silly going on. So let's go back and look and
Are
see.
you in radian or degree mode?
I'm actually in degree mode.
Because I'm in degree mode and mine's not graph. You need to be in
Wait, but how?
Or I mean, I'm in radian mode. You gotta go to Zoom. Go to Zoom. The question is, I'm having trouble seeing the graph and stuff. Go to Zoom and hit 7, and that'll put it in trig mode.
Mr. Adams.
Yes.
How did you get those black boxes around the equal signs and the y?
I'll show. That's a good question. Let me have this finished graphing. What's the x value for that blue line?
1.
No.
2.
Oh,
Negative 2 and positive 2.
Yeah.
What's tangent of 0? Do that on a separate screen. What's tangent of 0?
0.
0?
Yeah.
Yep. Okay. So what I'm going to do, the question was, and I have to do this anyways, they said, how do you turn those boxes on or off? I'm going to turn off the red one because I want to see why I have a blank space. But what I got to do is I just got to use the cursor, the up and down, left and right arrows, to get it to blink on the equal sign. And then I just hit enter. And now it changes from turning it on or off. If you have the filled in box, that means that it will show. If you turn the equal sign off, that means it will not show. So now when I hit graph, I should only see the blue line. What is tangent of 0?
0.
0. And what is this function here? 1 over tangent. So if tangent of 0, in other words, when x equals 2, I get tangent of 2 divided by 2, which is 1, which is was when tangent equals 0, is what I meant to say. We were saying it wrong. Is that defined? No, it's not. So it depends. You have to think this through because your calculator isn't set up to do cotangent. Sometimes it works better to do 1 over tangent, but really it's better to do cosine over sine. Do you see why?
Yeah.
Okay.
Mine didn't really work for 1 over tangent.
You're probably missing an extra set of parentheses or something like that. Okay, so now I guess that's all I have. You know the transformation. I just want you to see the different graphs. How is this transform? You guys answered it for me, but I'm going to pull this up here so we could see it. This is transform. If I just do cosine of x divided by sine of x, you'll see how it's transformed from cotangent to cotangent, all this other stuff. Let me just turn this graph on so you can see the full graph. So the red curve is the equation that we were given in the example that's transformed. And in about 2 seconds, we're going to get another curve, which is the regular cotangent. And we'll talk about the regular cotangent. Just guessing, since cotangent is the reciprocal of tangent, which means we're just flipping a couple things around, what do you think the period of cotangent? Well, wait, what was the period of tangent? Pi. What do you think the period of cotangent is?
1 over pi.
No. It's just pi.
Dang it.
Because really we're just flipping it around. So, but it is, where is the vertical asymptotes occurring though?
In cotangent?
Yeah, so let's look at cotangent for just a second. Let me turn everything off except for cotangent. So let me turn this off. So now we're going to talk about cotangent.
But you can just hit enter to turn off.
Yep, as long as you're above, if you're on the equal sign. So cotangent, what is in the denominator of cotangent? In other words, cotangent, remember that cotangent of theta is equal to cosine of theta over sine. When do we get those vertical asymptotes? When do we see vertical asymptotes?
2 pi. Pi over
Well,
2.
you guys are saying it, but let's talk about it.
Pi.
So what I'm saying is cotangent of theta is equal to cosine of theta over sine. We get our vertical asymptotes when sine of theta equals 0, right? Because that makes this thing undefined. All right, good. So now when does that occur? Well, if I make my unit circle, my perfectly drawn unit circle here,
Oh wow, that's beautiful.
where this is my x and this is my y axes, this is going to be 1, 0. This is going to be 0, 1. This is going to be negative 1, 0. And then this is going to be 0, negative 1. And remember, it's cosine of theta, sine of theta on the unit circle, right? So we're interested in all the y values. Well, this is 0, this is 0. That occurs at 0 and pi. And so we rotate around from 0 to pi, then from pi to 2 pi. And we rotate around again. That occurs at 3 pi. Now let's see how that looks like on the graph. I got a vertical asymptote at 0. I got a vertical asymptote at pi. I got a vertical asymptote at 2 pi. I got a vertical asymptote at negative pi and negative 2 pi. Negative 2 pi, negative pi, 0, pi, and 2 pi. You guys ready? You gonna help me out?
Yep.
Okay, so for this, cotangent of theta, what is the domain for cotangent of theta? All reals.
All reals except for...
N minus pi.
Yeah, except
No, N times pi.
k times pi. What would k be this time, though? K is just an integer. It's 0, 1, 2, 3, 4, pi. Multiples of pi. What is the range?
All
Ranges
real
all
numbers.
I have 2.
All reals.
Oh.
And then lastly, what is the period? How long before the cycle starts over?
Pi.
Pi. Now you know why that cycle starts over, right? Because here we have a value of 0. Here we have a value of 0. When does that start over? Here, here, here. And what's the distance between those two? Pi.